Good afternoon, class, or good morning, whenever you happen to be watching this video. So today we are aiming to cover chapter section 3.2. Um, we're going to be going over the chain rule and general power rule. Now we've already talked about the power rule when we have x squared or x cubed and such. But now I want to start talking about what if we have an entire function raised to some power? What do we do then? Well, that's where the chain rule comes into play, and the general power rule as well. So we're going to talk about that today. Once we cover those two rules, then taking those two guys, plus what we learned in the last lecture with product rule and quotient rule, you're going to be able to take the derivative of just about anything, which is really quite amazing. You guys should feel empowered by that. That's great. That's cool. There are some things that we haven't covered yet that I believe we may be covering later in the course. At this point, you'll be able to take derivatives of any polynomial times another polynomial, or a polynomial divided by another polynomial. Anything regarding polynomials, you're going to know how to take the derivative of, which is a good feeling. We still haven't covered derivatives for trigonometry, so sine, cosine, tangent, all that. We may get there later. We also haven't covered derivatives for exponential functions. So if you have e to the x, where e is the infinite number, or if you have like 3 to the x, 4 to the x, 2 to the x, whatever. That's a special case where you need a different kind of rule, but we're not covering that today. There's also, what's the derivative of the natural log? Or what is the derivative of the logarithm base 10 or base 3? What have you. So we have a few other cases that we haven't covered yet, but don't worry, we'll get there. So for the time being, really revel in the fact that you're going to be able to take the derivative of just about anything else, which is great. That's empowering for you guys. So let's go ahead and start on this second video here. Well, second video for me that I'm making today. I still have a little more coffee. Let's hope it gets me through. And then we will be done with the lectures for today. So, what are we doing? Section 3.2, and oops, I accidentally left this up from 3.1. But don't worry, I'll probably write that back up later. We're going to need the product and quotient rule at the end, because we're going to start combining everything. And it's going to be great, and it's going to be fun, and you're going to love it. Or maybe some of you will. I know I will. So, we're going to try it. Alright, so, section 3.2. What's the first guy we want to talk about? What we want to talk about is the chain rule. So what is the chain rule? Well, similar to before, let's let f of x and u of x be differentiable functions. Differentiable, and when I say differentiable functions, that just means they're functions that you can take the derivative of. There are some functions that are not differentiable. That's not going to be a big deal right now. That may be something we'll talk about later. But for now, don't worry about that too much. But just for context, that's what I mean when I say differentiable function. It's a function we can take the derivative of. So, chain rule. What are we talking about here? So, suppose y equals f of, but instead of x, what if I have a function inside of a function, f of u of x? So what's the derivative here? Then y prime, which is the derivative of y with respect to x, dy dx, is equal to, you're going to take the derivative of the outermost part first. What's the outermost part? F prime. So f prime times, f prime of we leave the inside part alone at first. So u of x doesn't change. We leave it alone on the inside. And then we multiply it by the derivative of the inside part. That's u prime of x. So when we have a function that's inside of another function, the derivative of such a guy is f prime of the inside part times the derivative of the inside part. And this is what we call the chain rule. Make sure you star this somewhere. This is something you're going to be using over and over again in the rest of the class, just as the product rule and quotient rule are things we're going to be using over and over again. So what else do we have? Next, we'd like to cover the general power rule. General power rule. So what is this? The general power rule is really, while we call it its own name and it has its own rule, it's actually based off of the chain rule, but I'll show that to you as we work through it. So suppose f of x is equal to x to some power n. That could be to the third power, the second power, fourth power, what have you. The point being it's some constant number, so x to the n. And then suppose we have some other function, g of x, that is also differentiable. Then, if y equals f of g of x, or in other words, that's g of x raised to some power n, then what's the derivative? Well, then y prime, you see that we have this f of g of x format? This is the same format as f of u of x. So what's our derivative? Well, it's the derivative of f prime with g of x plugged in, so we leave g of x alone, and then we multiply it by the derivative of the inside part, g prime. Okay, well that's all fine and good, but how does that apply with this power stuff? Well, what's the derivative of f? If we just ignore g of x for a moment, pretend it's just x by itself. If it's just x to the n, then what's the derivative of that? Well, that's just the power rule. We already know that. So the n comes down, and we're going to leave the x alone, or in other words, g of x. The power is going to decrease by 1, so it's going to become n minus 1. And then by the chain rule, we're going to multiply by the derivative of the inside part. And there you have it. There is the general power rule. The whole point of the general power rule is if you have a function raised to some power, what is the derivative of that? Well, then you take the power to the outside, leave the inside alone, decrease the power by 1, then multiply by the derivative of the inside part. Okay, great. So now what? Well, we have our general power rule. We have our chain rule. Let's start taking a look at what does this actually look like. So, for our first example, let's consider f of x is equal to, let me make sure I copy this down correctly, 2x to the negative second power plus 5x minus 3, all raised to the 3/2 power. So what do we do? How do we get the derivative of this? Well, obviously, I can't just raise everything to the 3/2 power. We can't do that. So there's not really any way for me to multiply this out so that I can get the derivative another way. I'm forced to use the general power rule, or in other words, the chain rule. So what do I do here? Well, just as the general power rule suggests, ignore the inside part to start with. Just cover that up. Think of that as just a regular ol' x. If I have x to the 3/2 power, what do? Well, the power comes to the outside. I leave the inside alone. The power decreases by 1. What's 3/2 minus 1? Well, that's just 1/2. Times, now I look at the inside, the derivative of the inside part. What is that? Well, -2 times 2, that's -4x. Power decreases by 1. -2 minus 1 is -3. The derivative of 5x is just 5. Derivative of -3 is 0. And there we go. So this is a perfectly valid way to write your answer. That's it. We're done. For those who are a little more picky, if you care, then yeah, you could multiply this out. So we would have 3 in the numerator times this guy in the numerator. So we'd have 3 times, that's a -4 divided by x cubed plus 5 times this half power, which is just the square root, 2x to the -2 plus 5x minus 3, all divided by 2. And if you want, you could distribute the 3 into here. I'm not going to bother with doing that because it doesn't really matter. Either way, whichever way you prefer to write your answer, this is good. That's your final answer, and we're done. There's your derivative. Okay, great. So now what? Well, for just a moment, let's think back to some of our business examples. So suppose you're given, and let me make sure I read off the word problem correctly. Suppose you're given here we go. Suppose you're given a manufacturer has determined that the weekly profit from the sale of X items is given by, so they give us the profit function. P of X is equal to -x squared plus 280x minus 4,000. So they give this to us. They also tell us some little extra information. It is estimated that after t days, so we're given another variable, after t days in any week, x equals 0.5 t squared plus 5t. X items will have been produced. So in other words, what is this telling us? Well, in any given week, we're being told that if we're in the first 2 days of the week, then you plug in 2 for this function. That's going to tell you estimated how many X have been produced, how many X have been manufactured. Okay, so that could be useful. So the question now asks, find the rate of change. So what's rate of change? That's a derivative. The rate of change of profit. Or in other words, if we go back to the business terms, that would be find the marginal profit. So we're looking for P prime. Find the rate of change of profit with respect to time at the end of 4 days. So it's interesting. They say rate of change with respect to time. In other words, that's dp dt. It's the derivative of profit with respect to time. This is very important here. We're not taking the derivative with respect to x, since that's how p of x is written, we're trying to take the derivative with respect to time. This is what we want. Well, in order to do that, we have to first have what is p of t. So we get that by taking this equation and plugging it in to change these x's in terms of t. So nothing too complicated. So p of t is equal to negative, make sure you have this wrapped in parentheses, 0.5 t squared plus 5t squared. Let me erase this for a moment. Plus 280 times x, so plug this function in again, 0.5 t squared plus 5t minus 4,000. So this is the expected profit based on how many days have passed during a week. Are we on day 1, day 2, day 3, so on. So we have this now. Okay, great. So what? Well, now we can find p prime of t, or in other words, the rate of change in profit with respect to time. This is very important, dp dt. As we start moving forward, you're going to start seeing this kind of stuff more often, where you're no longer taking the derivative with respect to x. And maybe you have to change some variables, maybe it's a different kind of derivative, so on and so forth. So pay attention to the wording in these questions. It does make a difference and it will change your answers. So keep that in mind. So dp over dt, we start with our derivatives here. So here on the left, we've got a function of t raised to the second power. Now, if you wanted to, you could go ahead and square this and write out what that is squared. That's going to take extra work, extra time. If you want to, absolutely go for it, but it's going to take longer. Instead, we're just going to use the chain rule again, or the general power rule. So what do we have here? So we're going to have the 2 comes down to the outside and leave our negative. So we got negative 2, leave the inside alone, 0.5 t squared plus 5t. Power decreases by 1, so it becomes 1, times the derivative of the inside part. Well, 2 comes down, that's going to give us 1t plus 5. And then over here, we have 280 times this function. Now remember from, I believe it's called the constant rule, if you have a function that's a constant times a function, you can just ignore the constant and take the derivative of this guy, and then multiply your constant on it again. So what is this? Well, that is 280 times the derivative of this guy. Well, we already know that. That's t plus 5. And then minus 4,000, the derivative of that is just 0. So there we have it. This is the rate of change of profit with respect to time. Very important here. But we want to know, find the rate of change of profit with respect to time at the end of 4 days. So when t equals 4. So we're just going to plug in 4. So 4 squared is 16 times 0.5. Well, hold on. Let me write this down. So we're looking for p prime of 4. So 4 squared is 16 times a half is 8. Plus 4 times 5 is 20. 20 plus 8 is 28. So we've got 2 times 28 times 4 plus 5 is 9. Plus 280 times 4 plus 5 is 9 again. What does that equal? Well, you can punch that in your calculator, and you are going to get 2,016. And there you have it. So that's your final answer, and we're good to go. Now, we've talked about using the chain rule in terms of the general power rule. But what if we're not using the chain rule? What do we do then? Well, sometimes you have questions written like this. And these are actually some examples that you're going to see in your Hawks Learning Certify. So sometimes you might be told that suppose h of x equals f of g of x, right? And maybe they don't tell you what f is, and they don't tell you what g of x is, so you don't even know if the power rule applies or not. You're not told anything about these functions. And maybe all they tell you is g of 1 equals -2. Maybe they tell you f of 1 equals 3. And maybe they tell you g prime of 1 is 1/2. And maybe they tell you f of -2 is, let's say, 6. And this is all the information they give you. And maybe they also, just for the heck of it, they throw in f prime of 1 is 0. Okay, this is what they tell you. They don't tell you anything else about what f and g are. But then they ask you, what is h prime of 1? And this is the question. What is h prime of 1? Well, let's just take it one step at a time and think about it. So what is h prime? Well, h prime of x, based on the chain rule, is f prime, and you know what? I actually wanted to change this here to 6 and this to 0. Sorry, let me change the numbers up here a little bit. So I changed f of -2 is actually 0, and let's say f prime of -2 is 6. Alright, so this is the information they give you. But what is h prime? H prime of x, based on the chain rule, is f prime of g of x, leave the inside alone, times g prime of x. And that's all we know. Okay, well then plug in some numbers. H prime of 1 is just equal to where x equals 1 in this equation. So that's f prime of g of 1 times g prime of 1. Now what's g of 1? We're told it's -2. So this is f prime of -2 times, what's g prime of 1? Well, we're told that's 1/2. So this is actually 1/2. But f prime of -2, up here it says that's 6. So we have 6 times 1/2, which is really 3. And there's your final answer. So in the case of this question, they don't even tell you what f and g are. All they do is tell you what maybe some of the coordinates are on this function, and that's it. And then based on that, they want you to tell them what h prime at that point is. And you can do that using the chain rule and then plug it in the numbers they give you. So this might take a little bit of practice. If you've never seen this kind of problem before, it may look very wonky. I've had many students come to me and ask about these kind of questions. They're really not so bad. Just take it one step at a time. Ask yourself, what is h prime? And just plug in what it is based on the rules we have. Once you've done that, work backwards and say, okay, what happens when I plug in these different numbers? And that's going to get you to your final answer, and it's actually a lot easier than some of the other questions that you'll deal with. But that's how this works. And this is an example where you have to use your chain rule without knowing if the power rule actually applies or not, because sometimes you don't even need the power rule. So there you go. Let's see. Oh yeah, we got time. We got lots of time. All right, so now we're going to start combining all the little tricks we've learned. So remember, product rule, if y equals f of x times g of x, then y prime is f prime times g of x plus f of x times g prime of x. We know our quotient rule from the last lecture. If y equals f of x divided by g of x, then y prime is equal to, this is equal to f prime of x times g of x minus f of x times g prime of x, all divided by g of x squared. There's our quotient rule. And then we also have our chain rule. And this says if y is equal to f of g of x, this is composition, you have a function inside of a function, then y prime is equal to f prime of g of x times the derivative of the inside part, g prime of x. These three rules are vastly important. You're going to use them over and over again. Make sure you know them. But now we're going to take a look at some examples where you have to use all three. And to be quite honest, sometimes these questions can become a little tedious and lengthy, but as long as you remember these rules and you just take your time, you're going to be able to plug along and get the correct answer. So don't worry about it too much. All right, so here's our three rules. This is what we want to use. Let's see what examples we've got to work with. Yeah, this is good. We'll start here. So suppose you're given, let's see, I'm trying to figure out where to stand so you can still see the rules. Well, you can see the rules here. Make sure you have them written down somewhere. Because I'm right-handed, I can't really stand on this side and write on the board, and you can see it. So I'm gonna have to stand on this side, unfortunately. At any rate, so yeah, let's go with this example. G of x is equal to x squared, and then we have the cube root of x squared plus 6. What do we do here? Well, first things first, notice we're dealing with a function divided by a function. We also can't simplify this any, so our only option is to use these rules we've learned. All right, so here we go. Start off by just taking it one step at a time. We have a fraction, so let's try to figure that out first. What's the derivative of a fraction? Well, that's the derivative of the top, so 2x, times the bottom, so just write the bottom, don't change it. So that's cube root of x squared plus 6, minus the top, that's x squared, times the derivative of the bottom. What's the derivative of the bottom? Well, in this case, note that we have this cube root. What is a cube root? Well, that's the same thing as x squared plus 6 raised to the 1/3 power. Okay, great. So what do we do? Well, then here we apply our chain rule. The 1/3 comes down, so 1/3 times x squared plus 6. Power decreases by 1. 1/3 minus 1 is a negative 2/3 times the derivative of the inside part. That's 2x. And there you go. So that's derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. Now what happens when you square something that already has a power? Well, you end up multiplying the powers. So what's 1/3 times 2? Well, that's just 2/3. So no big deal. We have x squared plus 6 raised to the 2/3 power. All right, so far so good. Now what do they do next? Ah, I see. They try to, well, we'll talk about it. Okay. So what do we get? Now we've got 2x cube root of x squared plus 6 minus, now we've got an x squared times an x. That's going to give us a x cubed. So x cubed. So we've used our x's. We've got 1/3 times 2, so that's going to be 2/3. And then we still have our x squared plus 6 raised to the negative 2/3 power, all divided by our x squared plus 6 raised to the 2/3 power. And there you have it. All we did was apply our chain rule and apply our quotient rule, and that's it. So this is a perfectly valid answer. There's nothing wrong with this answer. It does look a little messy with all of these 2/3 powers and this fraction here. It doesn't look super nice. So we can simplify this a little bit. But again, I'm going to leave that up to you guys whether you want to simplify it or not. As far as I'm concerned, that's a good answer. This might be a little bit harder to plug numbers in if you're actually trying to find the slope, but it will get you to the right answer. But for the sake of argument, how do we simplify this? Well, what's the numerator? Well, let's rewrite the numerator in a different form. So we've got 2x, and then we've got this x squared plus 6 to the 1/3 power minus 2x cubed in the numerator divided by 3, and we've got this negative power, so I'm going to move it to a denominator. So we've got x squared plus 6 raised to the 2/3, all divided by x squared plus 6 raised to the 2/3. So now that we have it written like this, quite obviously you can see, okay, we don't like fractions inside of fractions. So if I can get rid of this denominator, that's going to make this numerator a lot cleaner. So how do I do that? Well, I just multiply what I want to divide out. Multiply by 3 times x squared plus 6, all raised to the 2/3 power. But if I multiply that in the numerator, I have to do the same in the denominator. 3 times x squared plus 6 to the 2/3 power. As long as I do it to the top and bottom, then really all I've done is multiplied by a fancy 1, because it's the same number divided by the same number, so that's just 1. And as long as I do that, that's okay. This is perfectly legal. It's not changing the equation. It just allows me to simplify the fraction up here. So what do we get? Well, we're going to get, for this first one, 2 times 3 is going to give us 6x. When we multiply these guys, when you multiply and you're raised to different powers, this isn't the same as a power raised to a power. There you multiply. But here when you multiply two different guys with powers, you just add the powers. So this is x squared plus 6. And then over here, we're going to have the 3 times the 3 is going to cancel. And yeah, the 3 and the 3 are going to cancel. We're going to have minus 2. I have written here x cubed. And this x squared plus 6 to the 2/3 power is going to cancel with the x squared plus 6 to the 2/3 power. And so we're left with this 2x cubed. Although now I'm wondering if I messed up somewhere. Hold on, let me double check this, and then I'll come back to you. Okay, so as it turns out, there's actually no mistakes here. I'm just writing the answer a little bit differently than what the book has, which is what had me concerned, but it's fine. All of this here is perfectly good, so no worries. All right, so we keep going. We multiplied everything here in the numerator, so we're good there. Now we multiply the denominator. We've got 3 times, there's a 1 there, so we've got a 3 there. And then we multiply these guys, the x squared plus 6's, we add the powers. 2/3 plus 2/3 is 4/3. And there you have it. Now with the answer written this way, we don't have any more fractions. And, well, we do here in this power, but it's only in one place rather than having it in a bunch of different places. So this is nice. This is written a little bit better. And this would be easier to find your derivative. So that's a good answer too. But again, if I were to give you a question asking what is the derivative, I would accept either of those. So take your preference. They both have their different uses depending on the question you're working with, but I'll leave that up to you to decide which you like. All right, so there you have it. Okay, good. So we had to use the quotient rule and the chain rule in the same question, which at first maybe seems a little daunting, but so long as you take your time, you're going to be able to get through it just fine, and it's going to be good. Okay, let's see. We got time for another example or two. So let's see. What should we do next? Let's see, that's another chain rule and quotient rule. Let's use... Yeah, let's go with something else here. Let's work through... Suppose I give you h of x is equal to f of g of x times g of x all divided by f of x. And suppose I tell you, well, let's just leave it like this for now. And let's suppose you have this written, and the question asks you, what is the derivative? It doesn't tell you what f is, doesn't tell you what g is. This is all it gives you. What's our derivative? Well, again, this type of question is really just testing how well do you know these rules, and can you plug them together and use them together when you don't even know what the equations are. So this is a good example. So notice first that we have a fraction. We have a function divided by a function. So just to start off, think of this numerator, you can think of it as like a big F, it's some big fancy F, and this denominator is some big fancy G. So we have big F divided by big G. How do we get our derivative? Well, by the quotient rule, it's big F prime times G minus big F times G prime, all divided by G squared. Okay, so that helps us break this down a little bit step by step. So what do we do next? What is big F prime? Well, big F prime is this product of functions. We've got f of g of x times g of x. So we've got a function times a function. Or in other words, this is a product rule. So we've got a function, I'll call it little a, times little b. So what's the derivative here? If I need the derivative of the top, well, the derivative of the top, I'm going to have to use a product rule. So when I use my product rule here, and I'll put this in brackets, the derivative of this numerator is the derivative of the first, that's a prime, so that's going to be f prime of g of x times the derivative of the inside part, g prime, got to use our chain rule, plus f of g of x, that's just a, times b prime, which is times g prime of x. So it looks long and messy, but this is all the work we need to get f prime, or big F prime, I mean. So we had to use the product rule, f prime of g of x times g prime of x. We still need, see, even here I messed up. We still need to multiply by g of x, because this is supposed to be a prime times b, right? So f prime of g of x times g prime of x, that's just a prime, times b, that's g of x, now plus a, f of g of x, times b prime, g prime of x. So this is our big F prime, times g. What is g? Well, that's f of x. We got an f of x sitting out here. Now we subtract, and this is where, so I'm going to have to stretch this out. So I've got f prime of g of x times g prime of x times g of x plus f of g of x, g prime of x, all times f of x minus. So this is big F prime times g. Minus, I need big F, that's just the numerator. So f of g of x times g of x. So that's big F times g prime. What's g prime? Well, big G prime, that's just the denominator, the derivative of the denominator, which is f prime. And there we got it. We got big F prime times g minus big F times big G prime, all divided by g squared, which is what? F squared. And there you have it. Now this looks long and drawn out and kind of messy. I apologize for that, but it's simply the nature of the beast. When you have to take these derivatives and you've got a chain rule inside of a product rule, it can get quite lengthy, but again, just take your time, double check yourself, make sure you're plugging this all in correctly, and then you're going to get to your derivative. So make sure you know how to do this kind of thing. You can practice it a couple times, make some sense of it, and there you have it. So that was everything I wanted to cover for today in section 3.2. Of course, if you have any questions about this stuff, don't hesitate to email me, ask me questions, and of course we can talk about this during the Q&A. Otherwise, that's all I had for you. So as you work through your quizzes and homework, I wish you the best of luck.